Okay, so hopefully you had a chance to look at these 8 sequences, and now we'll just sort of talk through them about whether they're converging or diverging. And if you have questions, you can talk about it in class, and we can definitely come back to some of them when I'm back as well. So number one, I talked through briefly in the previous video. So this is what the first few terms are. As n gets bigger, of course, we're just going to have 1 over a really big number. And so this definitely converges, and it converges to 0, right? So it's approaching a specific number. Never quite gets there, right? But at the limit, it's converging to 0. Next one is sort of similar, but this numerator is sort of interesting. So I sort of wrote it out just from scratch here. And notice, of course, when you raise -1 to a power, you're either going to get +1 or -1. And so this first one is 1 over 1, just like in the last sequence. This next one will be -1 over 2. And then we're back to +1 over 3, and then -1 over 4, and so forth, right? So we'll write this out officially in a little bit, but this is called an alternating sequence. It's alternating between positives and negatives. And this one you might have a little harder time. Is it approaching a single number? Sort of looking at a little graph of the terms might be useful. So we start off up at +1 for term 1, and then term 2 is -1/2. And then term 3 is +1/3. So we're alternating back and forth between positives and negatives, but we can see that these numbers, even though they're switching sides of the x-axis, they are definitely getting closer to the x-axis. So this might be a little surprising to you, maybe not. This one actually also converges to 0. So these numbers, -1 to a power, will either be 1 or -1 divided by a huge number, will definitely be close to 0. So this is converging to 0 also. Next one, just the list of integers. This is definitely not approaching a specific number. This is going off to infinity, so we say this diverges. Next one, alternating, but not alternating, getting closer to 0. So it's going back and forth between positives and negatives, but they're getting bigger and bigger. This one definitely diverges also. Next one, here are the first few terms written out. Hopefully that worked out for you. 1/4, 2/5, 3/6, 4/7, 5/8. A little bit harder to tell just from those first few what's going on. But this, we can go back to some previous ideas. We're looking at k over k plus 3. When k is really big, like 1,000,000, we're going to have 1,000,000 over 1,000,000 plus 3. That is not quite equal to, but it's definitely very close to a particular number. It is converging to 1. And so it's sort of like finding the horizontal asymptote of that graph, right? It's not technically a graph, it's just those dots, sort of like we graphed up above, but it is converging to that number. Next one, you'll notice some patterns here. This is basically just like number 5, except it's alternating, right? And so now we've got a little bit different situation, right? Because we're going to be alternating back and forth between above and below the x-axis. But as we do that, we're either up close to +1 or close to -1. And they're not exactly equal to 1 and -1, right? But we're going to be getting some dots that sort of look like this, either getting closer to 1 or getting closer to -1, depending on whether we're on an odd or an even term. And so because of that, we have to say this one diverges. This one diverges. It's not approaching one specific number. Sign of 1, 2, 3, 4. Most of us don't know what these answers are off the top of our head because they're not sort of nice special unit circle values. But we know what the sine wave pattern it follows. It sort of goes up and down and up and down. And so we're basically just picking random dots along this sine wave. Definitely not approaching a specific number. So this diverges. And then last one, factorial. We'll review that in just a second if you weren't familiar with it, if you don't remember it. But basically, factorial is something that grows very quickly. So we have 1 over a really huge number. And this is definitely going to converge to 0. So again, feel free to pause the video here for a second, talk about any of these as needed, and try and clear up any questions. And if there are things that we need to come back to on Friday, we certainly can. Just to wrap up a couple things related to what was in these problems. So an alternating sequence alternates in sign, positives, negatives. Usually it will come about from powers of -1, and you either use an exponent of k or k plus 1, depending on whether you want to start with a negative or a positive. Sometimes they try and trick you. They do things like cosine of pi k. Think about your unit circle and think about why all this is doing is producing ones and negative ones. Factorial basically just means to multiply by everything from 1 up to the number, right? So 5 factorial means 1 times 2 times 3 times 4 times 5, 120, grows very big. We will get into factorials a lot down the road, and it's good to be able to do a little arithmetic with them. One thing that sometimes trips people up, 0 factorial shows up. We'll talk about this in more detail if you don't believe me, but for now, you just want to remember that 0 factorial is equal to 1. And then we can do some math with it, particularly when we're dividing factorials. So n factorial means everything from n down to 1. N minus 2 factorial means everything from, sorry, that keeps popping up, from n minus 2 down to 1. Notice when we write these out, we sort of have that dot, dot, dot there. And it just sort of, we continue as long as we need until we get down to 1, but we notice that eventually the lists are the same. And so basically the top and bottom are the same except for those first two things in the numerator. And so that whole mess just simplifies to n times n minus 1, which is definitely a handy thing to be able to do occasionally. And like I said, that'll come up a lot later in the unit. All right, you can stop here, take a little break, and then we're going to move into series.